Thank you, and thank you for the invitation. So this will be a small part of distraction for the end of the day for you, or also morning, with a little bit of what we do in academic field. And so I apologize, I have slides that are not so nice as the one of Capgemini. It's more traditional. So all the examples I will give you are coming from a researcher from PrAIrie, except when it is mentioned. So AI successes are not new. You have seen a lot of things in the press and news every day since a few times, even for Skype translator 10 years ago, before LLMs. On other things in robotics and so on. So it started a long time ago. I will not go back to this part because Juliette has already mentioned this morning. I just want to mention that all this idea about having things like neurons come from the idea of mimicking how vision is working in your brain. So the first idea was to try to reproduce what is done by your brain, and we will come back to this later. So the big boom we are living now has started in 2012 with this kind of I'm not very light is. Yes, all these layers of neurons, as mentioned by Julia this morning, that work very well on this benchmark. There are competition each year when all the academic people, researchers, are trying to have best result on common benchmarks. And this is, this is the error rates in image recognition, you know, this idea of recognizing cats and dogs and blah, blah, blah. And then it starts to be better than all the other algorithms using deep learning. And what is very nice to see is you have often this in research, you have a continuous progression and then a break and then continuous progression until the other break. And from this time, it has never stopped to be better and better and better. And the idea comes from, was the same as the one already used by Yann Lequin a long time before, to recognize, to automatically read bank checks in US. And if you see just a thing, this guy who was on the paper at this time, he was postdoc, is Elias Suskever, the one who was CTO of OpenAI when the big deal with Sam Altman. So Juliette has already mentioned that the problem with this kind of AI is that you need a lot of data. But we will stop a few minutes to think, what does it mean? It does not just mean that you have to collect or to be a owner of a lot of data in your company. You need, with this kind of technology, to annotate them because this is supervised learning. This means that, for example, for this kind of image, this is an academic database. Meta and Google have much more larger ones. You need that someone, a human being, is taking something to mark and color and write on each item what is it, where is a cat, where is a guy, and so on. So this kind of artificial intelligence was based on a lot, but really a lot of stupid tasks made by humans. More important, for language, it was also very expensive because this you can ask anyone to do it and pay a few cents to any kind of worker. But for this, for languages, you need to, at this time, so before LLMs, you need to have people with a lot of knowledge of each language, so linguists, annotating hand by hand grammar, links, and so on in text. And it is very, very expensive, even for a language like French. But if you want to have the same things for less common languages, at least with less specialists in the world, it's much more expensive. So since a long time, people were trying to find other ways, unsupervised learning without data. So this comes from a paper. They have used I have no video, but this is an extract of a video. They have used a film, movie, like this was Babe, just asking the algorithms to find some recurrency. And it always puts the square on animals, dogs, pigs, and so on, but it has inferred that the main characters of the movie are animals. You have things like this with other things, so there are images of bikes, planes, motorbike, and other things. And again, there was no previous label. It was just asked to the algorithms to find some similarity. And the clusters are very nice. But the algorithm is still stupid. It does not know then a bike has 2 wires, that a plane is flying, and so on. It's just classification. And at this time, for text, it was really not working very well because it was used small parts of text by small parts, sentences. And for example, if you look at this, if you are a Parisian, when you come to Bouchon sur le périphérique, you mean that there are traffic jams. But so the algorithm has no common sense. It's just try to translate the best way it can. If you look at this is a good example. Sentence by sentence, if you have this table is black, it means in French that it's a blackboard, because most of the time the blackboard are blacks. But if you want to sit 12 people, this means that this is a table when you can have a dinner. And sentence by sentence, you don't have the context and you cannot translate in a proper way. So you have also bias and so on, but I will go back. And now we had generative AI. So what has changed? This is not using supervised learning, but self-supervised learning. What does it mean? This means the easiest way to explain it is that you imagine a text, you hide one word of the text, and you ask the algorithm to predict it. But you know the answer, because the answer was the word you have hidden. So you don't need to annotate it. This can be very easily automated. So with this kind of things, you can use much more data because you don't need anymore that a human being is annotating. So you can have more data. It also uses transformers. This is a new technology that exploits also sequential natural data, but in a process that is not sequential. That is to say, you can do it much more quicker, doing several things in parallel. And you can also have a very large context. So it's not anymore sentence by sentence, but you can have a large part of the text used at the same time. And you have all of this, and this is what it's supposed to be written somewhere. This is also called attention mechanism, and in some way it comes back to mimicking what you are doing. When you have a text of something to read, maybe you will read it from the first word to the last one, or maybe you will have a quick look to understand what about is this text. This is the same kind of idea. And for the interface, it uses reinforcement learning. And now there are still a lot of problems. You have heard a lot of them in the 2 previous talks. For an academic point of view, for research, there are people working, for example, of the integration of rare languages, because it's very important for people to have access to AI everywhere on the planet, but it's very difficult because you don't have enough data. There are languages that are not written, so you have to be able to translate directly speech to data. You have things about code generation, and a lot of work are now working on multimodal approaches. That means using text and images at the same times. You have a lot of things to increase interconnection with external tools, especially to go to more explainability, like was mentioned by David this morning. And also plenty of other work, for example, on interfaces to include emotion and either in restitution or in understanding. For example, there are people working for an insurance company to detect when someone is calling his level of stress in the voice, to know if it is someone asking information about his contract, he can wait, or if it is someone who is calling because of an accident. It's very important. Explainability, I will skip because we have heard about this morning. And also causality, this means that people want next generation to be able to decompose tasks and to be more, let's say, autonomous in some sense, to analyze a complex problems like a human can do. There are a lot of problems about safety, data vulnerability, yes. I will show you 2 examples just after, and also things about culture and more. That is, for example, if you imagine you use ChatGPT, which has been mainly trained on US data, it's not just a question of language. It's also a question of culture. And for example, if you want to use it for a question in law, US are not using the same fundaments of law than us. So it's not the same way of reasoning. And especially not everything is text, and there are a lot of information in the world that are not in text. So for 2 examples, I will detail a collapse and adversarial attacks. The problem with data is that you can poison them, but you can also just have bad quality of data. And the more we are using LLMs, the more you have on the web data generated by LLMs. And there are increasing difference. The more you are using a type of word, the more it will appear in the result of LLMs. So, for example, this is an example of collapse. If you use 10 times the same model each time on the data he has generated before, after a certain times, if you read the 9th generation on the bottom, it doesn't mean anything. It's just because the data has become poor and poor and poor. So you can not only use synthetic data to train models. I think this is David that has mentioned this morning that it's sometimes very easy to attack foundational models. So this is an example with image, not with text. If you have an image like this, a nice cat, you can, with a very, very little change in the image, obtain a complete different result with generative AI. For example, here you have a cat, even in recognition, because this is clustering to decide if it is a cat or not. You add a little bit of noise in the images, and the algorithm can say that this is a dog. But for you, this is still a cat. Because for the way you are seeing the image, this is the same, but it has been changed.